Okay, let's jump into a new example now where we're going to conduct a two-sided or two-tailed test. So I thought this was kind of an appropriate example for Stat 1350. Who likes math? A claim is made by the Pew Research Center that 58% of Americans actually liked math when they studied it in grades K through 12. You believe that a different percentage of Americans liked math in grades K through 12. You survey a random sample of 250 adult Americans on this topic, and you find a sample proportion of 0.56. So notice here we're giving you lots of numbers, lots of really useful information to help you set up your hypotheses. So we start always with that claim about a population parameter. So here the claim is that 58% of adult Americans liked math in grades K through 12. You believe something different is going on. So this is really the key to look for in terms of deciding whether we should be conducting a one-sided or a two-sided test. So right from the start, you think something different is going on. You're not saying you think the true percentage is greater than 58% or less than 58%. You just think it's going to be different. So look for that keyword of different. You think something different's going on. So you conduct your own little survey. You have a random sample of 250 adults, so n equals 250, and then you find a sample proportion of 0.56. So p hat equals 0.56. So again, I always like to kind of just write down what I'm given in the problem, and then that makes it a little bit easier for me to plug things into my formula. Here again, if we write this in the form of a proportion, it would be 0.58, so I would just divide 58% by 100. So I have P, I have P hat, I have N, I have all that I need now to actually conduct my hypothesis test. So first of all, what would our hypotheses be? So our claim is that 58%, or a proportion of 0.58, liked math. We think something different's going on. We think it's not 0.58. So again, remember I have these three parts here. I have my P, I have my claimed value, and then I have that sign. And now we want to conduct a hypothesis test, and our alpha level is going to be 0.05. So here, remember, is the symbol for alpha. So we try really hard to always give you an alpha. If for some reason we forget, we don't specify what it is, just assume it's going to be 0.05. Okay, let's get going. And if anyone's interested actually in reading about this, this was based on this is true. So the Pew Research Center really did claim this and found this in a poll that they conducted. So if anyone wants to go and read more about it, please, the link is here. Please go and check it out. Okay, so again, the steps. So our null is P equals 0.58. The alternative is that P does not equal 0.58. And what I always like to do is I just draw that sampling distribution. For me, it helps. I can look at that distribution. I can see where my sample statistic is actually falling on the distribution. So remember, our p hat was 0.56, and I can see that's over here somewhere. So it's not really terribly far away from 0.58. So already I might be thinking, maybe I don't have enough evidence to actually reject the null. But it can help you in that it can help you gauge whether you have a p-value that's within the range of what it should be. So the test statistic, z equals p hat minus p all over p times 1 minus p over n, so the square root of that whole thing. So I'm going to probably leave out a few steps here. I'm not going to go through every single calculation, but I encourage you to go back, check my work, let me know if you see any errors. I try not to make errors, but occasionally something slips through the cracks. So 0.56 minus 0.58, and then I take 0.58, 1 minus 0.58, all over 250. So I have to find the square root of this whole thing. I always encourage you to kind of break this up and do your calculations in steps. So I would first find what's under the square root sign in the denominator, and then I'd take the square root of that value, and then I would find what the numerator is and divide that by whatever I get. So in the end, I ended up getting negative 0.7. My denominator was roughly about 0.03, and I'm doing rounding here. So if you work through this also and get something a little bit different, don't panic. It doesn't mean you did anything wrong. I can certainly check your work if you want me to, but we might each round in a slightly different way, and I'm certainly okay with rounding as long as you show your work. So we might get slightly different answers, but hopefully they'll be close. The denominator I got was I think I already said that. It was roughly about 0.03, and that's what allowed me to draw the sampling distribution. So I start at 0.58, which is that claimed population value, and then I go out 0.03, 0.03, I go down 0.03 in the other direction. So that's where I'm getting these numbers, in case you were curious about that. Now, what's my p-value going to be? Well, let me actually move over here. So here's a small little snippet from table B. I'm going to want to go to negative 0.7 in the table, and you'll see that gives me a percentile of 24.20. Now, if you think back to the slide I showed a little bit earlier, since we're doing a two-tailed test, we need to multiply that percentile by 2. So this is just giving me this one tail, but I want to know what would be in the other tail as well. Or I want to think back to the fact that originally I said I was going to look in both tails, and I need to now carry that through. So 2 times 24.20 is going to give me 48.40. Now that's a percentage or a percentile. I want this to be in the form of a probability. So now I'm just going to divide it by 100 to turn that into a probability. So I'm going to get 0.4840. So that's going to be my p-value. So again, because our test statistic is negative here, we go to table B, we find the percentile, multiply it by 2, and then divide the result by 100 to convert it to a probability. How should we decide if we're going to reject the null? Well, we're going to compare our p-value to alpha. Oops. So sorry about my writing. Compare p-value to alpha. So remember, if the p-value is less than or equal to alpha, we know we're going to reject the null. If it's greater than alpha, we are not going to reject the null. We're going to fail to reject the null. In our case, our p-value is greater than alpha, or 0.4840 is obviously greater than 0.05. So I'm not going to write this here, but in terms of in the context of the problem. So we are going to fail to reject the null hypothesis. So that's a very general way of saying things. We're failing to reject the null because our p-value is greater than alpha. Now, in the context of the problem, what we're saying is that we do not have support against the claim that 58% of adult Americans liked math in grades K through 12. We do not have support against that claim. We're not saying that claim is true. We're just saying that with this particular hypothesis test, with our sample of data, we don't have enough evidence against that claim. So when we say putting it in the context of the problem, think about what the original claim is, and try to write a sentence where you tell us whether you're supporting that claim or whether you're not supporting it and why. So we're supporting it because we got a large p-value. We don't have enough evidence against it. But again, that doesn't mean we're saying it's true. We just cannot reject it. Okay. The next few slides I'm going to go through very quickly. I mostly want you to know they're here, and I want you to come back to them often. Hopefully you will as you're working on future assignments. But we often get a lot of questions about, I'm not really sure if I'm working with a mean or a proportion. I don't really know what sign should be in my alternative hypothesis. And so the next few slides are just meant to give you some things to think about. I'm not sure how to find the p-value. If I'm doing a two-tailed test, how is that different from a one-tailed test? So first of all, if you're not really sure you're understanding if you have means or proportions, we're going to go through some more examples here soon, some with means, some with proportions. Hopefully it's starting to make sense. But if not, look for these keywords. So if the problem is about means, we are generally going to say something about an average or a mean. We're going to actually use those terms in the problem. Also, if the problem is about means, remember that if you think about the type of information that's collected from each individual, it would be quantitative information, an amount of something. And we're always going to give you a standard deviation. So along with the sample average or a sample mean, we'll give you a standard deviation. We often leave that out when we're dealing with proportions because it's a little bit easier to compute a standard deviation with proportions. And actually you don't really need a standard deviation. Well, when you're figuring out your z statistic with proportions, you just need p hat p and your sample size. So those are the only things you need to actually figure out z. So those are the things that we'll give you. With a test about means, you need the sample mean and the sample standard deviation to figure out the z statistic. So we'll always give that to you. We would never expect you to compute that. You might remember back from chapter 12, it's a little cumbersome to compute that. It's challenging if you have lots and lots of data values to compute something like that by hand, and we won't expect that. If the problem's about proportions, look for words like percentage or the percentage sign. Look for the word proportion. Again, most times we won't give you a standard deviation along with proportions because you don't actually need that to compute the test statistic. And also quickly, again, if you're trying to figure out the direction of the hypothesis when you're conducting a hypothesis test, look for things like greater than, bigger than, more than, or too low. That means you should get the greater than sign in the alternative hypothesis. Look for smaller than, less than, too high, things like that to know that you should have the less than sign in the alternative hypothesis. And things like different, differs, something other than, you're not making a prediction in one particular direction. So that's a clue that you're going to get that not equal sign. And then finally, again, the last few slides are just more details about calculating p-values. So if you're really struggling with that, pay attention to these and come back to these as you're working through other problems on assignments. If you have the less than sign versus the greater than sign. So remember when you have the greater than sign, so both of these would be one-sided or one-tailed tests, but if you have the greater than sign, remember when you go to table B, that percentage is not your final answer. You have to subtract it first from 100 to get what's in the upper tail. And then again, if you have not equal, how you figure out your p-value is going to depend on whether the test statistic is negative or positive. Okay, so I'm going to pause here, and then when we come back, again, we're just going to work through some more practice problems and also talk about some of the new ideas that are coming up in Chapter 23.